Okay, so this is test number 15. The first question. In fluid mechanics, the Froude number is a dimensionless number used to determine the behavior of a ship or object moving through water. It is defined as equation V is the velocity, G is the gravitational acceleration, dimensions of Froude number is. Okay, so we have this equation V divided by GL root. So the dimensions of both sides should be the same. Dimensions of velocity, that is LT minus 1. G gravitational acceleration LT minus 2. Length, capital L, then you have to take the root of that. So this is LT minus 1 divided by L squared T minus 2 root LT minus 1. So these two cancels off, then the dimensions, that is just 1, meaning the Froude number does not have any dimensions, just 1. So the answer should be the first one. If you, and the first one, they have given M not L not T not 0 means the power is 0 for all. So the value of these two things should be 1. So the answer is the first one for the first question. Second question. Which of the following readings is taken from a traveling microscope in the lab? Okay, so they're asking about a traveling microscope. So you should know the least count of a traveling microscope because you've been using the traveling microscope for a lot of experiments when you are doing. Okay, so this one you should know, like in a traveling microscope, main scale has 0.5 millimeter marks. Main scale is calibrated in 0.5 millimeter marks. 50 0.5 millimeter marks is divided, main 0.5 millimeter marks, it is like it is divided into 50 vernier marks. It has 49 0.5 millimeter marks divided into 50 vernier marks. So the equation to find the least count, so I'll use a simple version of the equation. Least count of main scale divided by number of parts in the vernier scale. So the least count of the main scale is 0.5 millimeter. It is divided into 50 parts. So this is 1 over 100, which is 0.01 millimeters. So 1/100th of 1 millimeter is the least count of a traveling microscope. So this is the vernier scale contained in a traveling microscope that is available in the lab. So like 0.5 millimeter, 49 0.5 millimeter parts is divided into 50 vernier parts in those vernier scales in the traveling microscope. You should know that when you if you did experiments using the traveling microscope in the lab. Okay, so to 0.01 millimeters. So in centimeter, this is 0.001 centimeter. Convert it to centimeters, just divide by 10. So because 10 millimeters is 1 centimeter, 0.001 centimeters. So from this, we can gain accuracy up to 3 decimal points. So just check 4 values that have 3 decimal accuracy up to 3 decimal points. So you can see B and D. B and D are the those numbers. So the answer should be third one for the second question. Third question. Following figure shows a graph which shows the variation of a physical quantity of an object in motion with time. According to the given graph, which of the following statements are false? So what they asking is the false equation. The graph given is like this. So as you can see, if you think about the gradient of the graph, this is the most important property. Gradient of the graph is increasing, right? Just draw a tangent to each position, then you can see the gradient of the graph is increasing. Okay, so first question, first choice, if the velocity of motion is indicated by y, this object moves with acceleration. Okay, so they say if this is y, velocity, y-axis is velocity, this moves with acceleration. Yeah, like this has a gradient, so this always has acceleration because the gradient of a vt graph gives us the acceleration. So this has a acceleration, but that acceleration is increasing actually. So in essence, like this has an acceleration somehow, but it is an increasing acceleration. This has an acceleration, right? Because this has a gradient. Okay, second one, if the displacement of the motion is indicated by y. So they say if displacement is indicated by y, the object moves with an acceleration. If this is displacement, so gradient of a ST graph is equal to velocity. Gradient of a ST graph is equal to velocity. As you can see, the gradient is increasing. Gradient is increasing, meaning the velocity is increasing. So it should be an acceleration. If the velocity is increasing, it should be an acceleration. So the second one also is correct. Third one, if the velocity of object indicated by y above motion has started from rest. Okay, so they say velocity, if this is velocity, so when t equals 0, velocity is 0. So it is true that the object has, if this is velocity, the object should have started from rest. Then fourth one, if the displacement of motion is indicated by y, so this is y, that is displacement. The gradient of the graph gives the amount of motion started from rest. So if this is displacement, gradient is velocity. Because in a displacement time graph, gradient gives us the velocity. If you observe this carefully, you can see if y is displacement, initially there's a gradient. When t equals 0, there's a gradient already. So it is not like this. It is like this. Graph is like this. So already this has a gradient when t equals 0. Meaning that at t equals 0, there's a velocity. It is so if this is displacement time graph, there's an initial velocity that is non-zero. So fourth one is the wrong one, right? That's a false statement. Then a velocity indicated by y, gradient gives us rate of increase of velocity. So that is just acceleration. So the fifth one also is correct. Fourth one is the fourth one. So that's the answer for third question. Fourth question. A particle starting from rest has a velocity that increases linearly with time as v equals kt. Then the distance covered by it in the first 3 seconds is, they're like many ways to do a question like this, like you can use like calculus, but here we are not going to use that because that is not in the syllabus. So the equation they have given is V equals KT. So this is just a familiar equation. So just relate this equation with the equation we already know. Just put a 0 here. U plus AT. So you can write this equation in this form. So if you compare these two equations, you can see that initial velocity is 0 and the acceleration is k. Initial velocity is 0, acceleration is k. So what they ask is the distance. So to find the distance, just use this equation. So the initial velocity is 0, acceleration is k. So what they ask is when t equals 3 square. So 3 square 9k divided by 2. This is the displacement after 3 seconds. So the answer should be the fourth one. Question. Two forces have magnitudes in the ratio 3:5 and the angle between their directions is 60 degrees. If their resultant is 35 Newton, their magnitudes are. So they have given two forces and the ratio of two forces is 3:5. So if it is 3:5, I'll use this as 3p to 5p. So 3p and 5p are the two forces. If the ratio is 3:5, 3p and 5p are the two forces. I can take it like that. Then you have to use this equation R squared equals p squared plus q squared plus 2pq cos theta. So p squared you can substitute 3p squared. Instead of q you can use 5q squared plus 2p means 3p. So this is a p force, this is a q force. Q is 5p times cos angle is 60 degrees. Cos 60. They have given the resultant as 35 Newton. So 35 squared. So 9p squared, 25 p squared plus 6 times 3. So cos 60 is half, right? Cos 60 is half cancels off. 3 times 5, that is 15 p squared. Then 34 plus 15. 49. So 49 p squared equals 35 times 35. So 7 times 7 is 49. That's a 175. 175. 5 times 5, 25 equals p squared. So p is equal to 5 Newton. P squared equals 25. So p is equal to, if you take the root from both sides, p is equal to 5 Newtons. Okay, so we found what the value of p is. Initially we took the forces as 3p and 5p. So one force should be 3 times p, that is 3 times 5. Other force should be 5 times 5. So 15 Newtons and 25 Newtons are the two forces. So there is no other way to find this. You just have to use this equation which you learned in when you do vectors, right? R squared, p squared, q squared, 2pq cos theta. So the answer is second one for fifth question. Sixth question. A ball of mass m thrown upwards with velocity v if air exerts an average resisting force capital F, velocity with which the ball returns back to the thrower is. Okay, so this is not just throwing a ball upwards and it falls down. The difference is there's air resistance is involved. Okay, so when the ball returns to the thrower, its velocity is not equal to v. It's a different velocity. So what happens is it goes up and the initial velocity is v. The ball returns. When it returns, velocity now is different because of air resistance. So let's say that velocity is v dash. And let's take the maximum height that the ball moves upwards is capital H. Maximum height. Okay, so the easiest way to do this is using energy equations. We can use Newton's laws as well, but easiest way is energy equations. Okay, let's say this is 1, 2, and 3. Those are the points. I'll apply energy equation between like 1 and 2. 1 to 2. Okay. So air resistance, that is a resistive force. So as the object goes up, resistive force is acting downwards. So from here to here, the resistive force is acting downwards on the mass. When the object moves downwards, resistive force is acting upwards. Okay. So the purpose of the resistive force is to reduce the energy that it contains. Okay. First, at point 1, it is given a kinetic energy. So that kinetic energy is half mv squared. Kinetic energy here. Then if you think about here at the top, it is at rest, instantaneously at rest. It doesn't have a kinetic energy at the top. But it has potential energy, that is mgh. Kinetic energy and potential energy, they are not the same now, right? This is the total energy given. Part of this kinetic energy, this is the total energy given, is consumed to increase the potential energy, and the other part is consumed by this resistive force. That work is done against the resistive force in order to go from here to here. So mgh plus work done by resistive force, that is fh. Force times distance. This is the distance is traveled, right? So this kinetic energy given is consumed by the potential energy and the work for the resistive force, work against the resistive force. Okay, so this is, I'll just further simplify this. mg plus f, I'll take capital F out. So this is the first equation we will have. So what we need to find is v dash. So I'll apply equations from 2 to 3. 2 to 3. Okay. Okay, let's think about the energy here. That is half kinetic energy, half mv dash square. That's the kinetic energy here. So this is the remaining energy. Let's say the energy here at the point 2 is, the potential energy is mgh. As the object moves from here to here, from that mgh, fh amount is reduced, that is consumed. So mgh minus fh. mgh, that potential energy is reduced by fh amount, because this F is the resistive force. So the remaining energy should be the energy here. So that is just half mv dash square. Okay, I will just simplify this further. mg minus F, take capital H out. So this is equation 2. Then I will divide equation 2 by equation 1. As you can see, there's capital H here, not capital F. When you divide these, half mv cancels off, half m cancels off. Then what you get? V dash squared, V squared equals mg plus F, sorry, mg minus F divided by mg plus F. That capital H cancels off when you divide them. Then take the root from the both sides. Then this becomes V root mg minus F divided by mg plus F. This is how we find that velocity V dash. So the answer for that should be the third one for that question. This is like the easiest way you can do this. Like there's no any other easy way. Like you have to follow, like apply energy conversions from 1 to 2, then from 2 to 3. You really have to understand like the energy conversions, the how much energy conserved, how much. So you should be able to do energy balances, right? So in this question, there are 3 types of energy. That is the work done against the resistive force, mgh, potential energy, and the kinetic energies. So you have to be able to understand these, how to write these energy balancing equations. Okay, so the answer is third one for the 6th question. 7th question. Fluids through pipes with cross-sectional area A1, A2 feeds the pipe with cross-sectional area A3. Speeds of fluid at A1, A2 are V1, V2. Speed of fluid through A3 is. So this question is from hydrodynamics. So we have 2 pipes. And those 2 pipes provides liquid to this third pipe. So the cross section is given A1, here A2, and the cross section here is A3. So what they ask is this velocity of the fluid through the pipe 3. Okay, so velocity here V1 and velocity here V2. Okay. So the volume of the liquids should be like, cannot be changed, right? Okay. So the we know this equation like volume flow rate is A over A times V. Should know this. Like this is the cross sectional area, so it has square meters cross sectional area times the velocity is meters per second. So this is cubic meters per second. So AV equation always gives us A times velocity of the fluid gives us the volume flow rate of a liquid. Okay, just so the volume flow rate here is A1 V1. Volume flow rate through other pipe is A2 V2. And the volume flow rate here should be A3 V3. That is the third pipe. So these 2 pipes, the volume liquids from these pipes is added into this third pipe. So the volume flow rate should be added. Volume flow rate here plus here should be equal to volume flow rate at the third pipe. So we can write A1 V1 plus A2 V2. Those sum of these 2 is equal to volume flow rate of the third pipe, that is V3. So in the question they ask, what they ask is V3. Just V3 is equal to, just divide by A3. A1 V1 plus A2 V2 divided by A3. So that is V3 velocity of the fluid through the pipe 3. So the answer should be the fourth one for the seventh question. Question number 8. When a car weighing 1000 kilograms moves at 18 kilometers per hour, power generated by the engine is 20 kilowatts. If the resistive force on car does not change, when the power of the engine is increased to 25 kilowatts, acceleration of the car is. So initially the car is moving at a constant velocity, but when the power is increased in the engine, the car starts to accelerate. So we have this car that is 1000 kilogram and it is moving at 18 kilometers per hour. Just convert it into meters per second, so multiply by 5 over 18. So that is 5 meters per second actually. So that is the velocity of the car. Since the car is moving at constant velocity initially, let's say F is the driving force, that is the force provided by the engine, and if capital R is the resistive force, if it has a constant velocity, these two forces should be equal. Horizontally, the forces should be balanced, so they should be equal. Then to the car, I will apply this equation, power equals FV. I am applying equations for this case when it is moving at constant velocity. So power is equal to FV. F is the driving force. V is velocity, that is 5. Power is given as 20 kilowatts. 20 kilowatts, so 5 4 cancels. 4000 Newton. So the driving force at this instant, when the car moving at constant velocity, is 4000 Newton. Since F and R equals, R also should be 4000 Newton. So now we found the resistive force acting on the car. That is 4000 Newton. Okay, they say when the speed increases, at the second case, the resistive force does not change. So the resistive force remains 4000, but the driving force increases. Okay, then they increase the energy, power of the engine to 25 kilowatts. Let's say the driving force now is F dash, but the resistive force remains as 4000 Newton. So what they ask is acceleration in this case. Okay, so for this case, I'll just apply this equation once more in order to find F dash. So power is 25 kilowatts. F dash we don't know. We can take at the initial moment V was 5. Okay. So when considering that, we can say that F dash should be 5 times 10 to the power 3 Newton. Now the driving force has increased to 5000 Newton. So F dash is 5000 Newton. So as you can see, now driving force is 5000, resistive force is just 4000. So there must be an acceleration to this side. In order to find the acceleration, we have to apply F equals ma. So 5000 to this side, 4000 to other side. Mass of the car is 1000. Acceleration 1000. Then acceleration is 1 meters per square second. So this is the acceleration of the car. Okay. So we have to really understand what is happening there. So the when the power is like 20 kilowatts, the car couldn't accelerate. It only has a constant velocity 5 meters per second. But when the it is increased to 25 kilowatts, car started to accelerate. So that's what we just found. So the answer should be the first one for the 8th question. Question number 9. Cylinder with moment of inertia I is free to rotate around its symmetrical axis. A mass M is attached to the surface of the cylinder by a string which is coiled around it. If mass M is released from rest, angular velocity of cylinder where the mass M moves down a height simple h. So I'll just draw a sketch. So let's say this is a cross section of the cylinder. So it starts from here, like then it, as the cylinder rotates, it falls down a simple h height attached to the. So this is rotating, then this mass moves vertically downwards. So what they ask is when this mass is at depth simple h, the velocity. Initially the system is at rest. Moment of inertia is given as capital I of the cylinder. Okay. So here the cylinder also rotates. And the radius is simple r. Radius is simple r. Okay, so we have to find this v. Right. I'll apply first equation just to cylinder. Tau equals I alpha. So this is like F equals ma. Moment equals moment of inertia times rotational acceleration. So the only force acting on the cylinder is capital T, and the normal distance to it is simple r. T times simple r, that is the only torque around the axis. So I'm applying this equation around the axis of the cylinder. T times r. Then the moment of inertia around the axis they have given as capital I. Then get this alpha. So TR equals I alpha. So that is one of the equations. Okay, then I'll apply F equals ma to this mass. I need to find, so this has a linear acceleration, right? This is having a linear motion. So to find the linear acceleration, I apply F equals ma to simple m, this simple m. Downwards. So downwards force mg, upwards t equals m times a. M times a. Okay. Actually, what we need is this simple a. From the first equation, we have TR equals I alpha. Instead of T, I can substitute I alpha divided by R. I alpha divided by R is T. This is equal to MA. So in order to find this V, what we need is linear acceleration. Simple A is what we need. So mg equals ma plus I alpha divided by simple R. Okay. m. So this linear acceleration is equal to a simple r. You know that tangential acceleration, that is at, that is also the linear acceleration, is equal to alpha times radius. So I just applied alpha r plus I alpha divided by r. So what you get is, if you take the common denominator, m r squared alpha plus I alpha divided by r, this is equal to mg. Take alpha out of this. I'll solve that here. Cross multiply mgr equals mr squared plus I alpha. Then you can find alpha. So that is mgr divided by mr squared plus I. So that is alpha. So in the question, what they ask is not linear velocity, but they ask is the angular velocity of the cylinder when this reaches from here to here. So we'll use this equation. Omega equals omega naught plus alpha. We don't know the time, right? So we'll use omega squared omega plus 2as. Actually 2 alpha theta. Alpha theta. So initial angular velocity is 0. 2 alpha. Alpha means this value, right? mgr divided by mr squared plus I. Then we have this theta. So this theta is in radians. So if you know this equation, S equals r theta, the distance it traveled is simple h and it is around simple r. So theta is equal to h over r. So substitute h over r here. So r cancels off. This becomes 2 mgh divided by mr squared plus I. So that is omega squared. So just take the root from the both sides. So omega is 2 mgh divided by I plus mr squared root. So this is the angular velocity of the cylinder when simple line moves from here to here. So the answer for that should be fourth one for the ninth question. Question 10. Tangential velocity of a particle moving in a circular path with radius 50 centimeters varies with time t according to v equals 3t. Find centripetal acceleration of particle when t equals 4 seconds. V, t in meters per second and s in order. Okay, so we have a circular motion and the tangential velocity is v. That v is given as 3t. Find the centripetal acceleration of particle when t equals 4 seconds. Okay, so the equation for centripetal acceleration, that is the acceleration towards the center. Let's say there is a radial acceleration AR, they are both same. So that is equal to v squared over r. So from this equation you can find velocity, tangential velocity when time is equal to 4 seconds. So that is 12 meters per second, that is the tangential velocity when t equals 4. Then just substitute it here. 12 is squared divided by radius is given as 50 centimeters or 0.5 meters. So 0.5 means half. It goes to denominator, it becomes 2. 2 times 12 is squared is 144. So 288 meters per square second. So that is the radial acceleration when time is 4 seconds. Okay, so this usually we learn like most of the questions in circular motion, the velocity is a constant. Not the velocity, the speed is a constant, but here the speed is increasing with time. Okay. So this is the centripetal acceleration when time is 4 seconds. So the answer should be the fourth one. The 11th question. When a metal cube is hanged by a spring balance, reading is 2 kilograms. Reading of the pressure balance is 5 kilograms. If the cube is immersed, reading of the spring balance is 1.8 kilograms. Then reading of pressure balance is. Okay, we have this spring balance. Then the pressure balance. Now it is not immersed. This mass is not immersed. So reading of the spring balance is 2 kilogram. Meaning the tension here should be the 2 kilogram. 20 Newton. And the reading of the pressure balance, that is the capital R. That capital R is 5 kilogram. You can think about the forces in terms of masses here. You just have to divide it by 10 and take it here. Okay. Then the next they say when this object is immersed, the reading here becomes 1.8 kilogram. Reading here becomes 1.8 kilogram. So when that object is immersed, what happens is there's an upthrust acting on that object additional to the mg. So due to this upthrust, since the upthrust is acting upwards, this reading decreases. So the decreased amount is 0.20, 0.2 kilograms. So this is due to the upthrust. See, 0.2 kilogram is due to the upthrust. Meaning that upthrust acting on this object should be equal to 0.2 kilograms. I am thinking of forces in terms of masses, right? So, like, you don't have to think about, you don't have like multiply this by 10. This is an easier way to solve a question like this. Okay, so 0.2 should be the upthrust. Okay. So as a result of immersing this object here, the only difference is there's a downward thrust. That is the reaction force of the upthrust acting on this liquid below here. So that is equal to 0.2 kilograms. So initially this the reading was 5 kilogram from the pressure balance. But here this 0.2 also should be added to that reading, because that pressure on the pressure balance there's this 0.2, that is the reaction of the upthrust acting downwards. So the reading of the pressure balance should be now 5.2 kilograms. It increases by 0.2 kilograms. The answer should be third one for 11th question. We can solve this equation using like a bunch of equations. U equals 0g, then thinking about force equilibriums in each case. But here you don't have to, because the mass can be considered as the forces. Then it will simplify things, so you can get the answer quickly if you get a question like that. Okay, answer is third one for 11th question. A balloon filled with hydrogen weighing 30 kg is held by a string if the volume of the balloon is 100 cubic meters, tension of the string is density of hydrogen and air is given. Okay, so we have this balloon, and this is the string. Since the density of hydrogen is less, so this is in air, it is less, so the balloon is trying to go up, but it is balanced by this string. The volume of the balloon is given as 100 cubic meters. Weight of the balloon is 30 kilogram. So that should be 300 Newton. Yes, the balloon, 300 Newton is the weight of the balloon without hydrogen. So they have given the density of hydrogen. So you can find the mass of hydrogen inside the balloon. Just multiply mass of hydrogen 0.09 times 100. So there is 9 kilograms of hydrogen as well inside the balloon. So 9 kilograms makes a weight of 90 Newton. So the total weight of the balloon should be 390, 30 plus 9, 39, then 390 Newton downwards. That is the total weight of the balloon. Total weight of the balloon. Another force acting on the balloon is U, that is the upthrust, caused by the air around the balloon. Well, I can find the upthrust as well. V rho G. So the volume is 100. Rho means the air density. That is the fluid that the balloon is in. So air density is given as 1.3 and the gravitational acceleration. And you have 1,300 Newton. So the upthrust is 1,300 Newtons. So in order to find the tension, now you have to find the tension. You just have to get a force equilibrium for the balloon. Okay, so I'll put that downwards. So the downwards, there's tension acting on the balloon is downwards, T. Then the weight also downwards plus upthrust is acting upwards, so that is 1,300. This is equal to 0. So T plus 390 equals 1,300. T equals 1,300 minus 390. 300, if you do the calculation, 1,300 minus 390, you get 910 Newton. So that is the tension of this string. That is 910 Newton. So since they have given the density of the hydrogen, and that is considerable amount, right? Like 9 kilogram. So you cannot neglect the weight of the hydrogen. But there are some cases we neglect that. But in this case, you cannot neglect the weight of the hydrogen inside the balloon, because it is a large volume of hydrogen. Okay, so the answer should be the second one for 12th question. 13th question. A wooden block with mass capital M floats on water. So 1/4 of its volume is above water. If M mass is placed on top of it, the wooden block just sinks fully. So what they ask is what is the combination between simple M and capital M? So here we have just this box, capital M. but 1/4, let's say the total volume of this is capital V. So 1/4 of that volume is above. So this is VO4. This amount should be 3 VO4. Immersed amount 3 VO4. And this has a mass capital Mg. Then let's say the upthrust is U1. Since this is floating, the upthrust and Mg should be equal. So U1 volume is 3V, displaced volume 3VO4. Then the density of water, let's say that is Froude. It is not given, so I put as Froude. G equals mg. Then G cancels, so 3VO4 is equal to m. So this is the equation for first case. Then at the second case, when you place simple m, mass on top of capital M, total thing, whole thing just sinks below the liquid level. Then again apply upthrust, force equilibrium. Now the total weight is m plus mg. Upthrust, let's say U2. So U2 equals m plus mg. So U2 is now the displaced volume is V. The whole thing has like sinked. Capital M has completely sink. So it should be V, then rho G equals m plus mg. I'll cancel G, then V rho equals m plus m. So that is the second equation. So what we need is, so we have V rho here. Then you can substitute this V rho, meaning capital M plus simple M here. So you have 3/4. V rho is capital M plus simple M. That is equal to capital M. Then 3/4 of simple M plus 3/4 of capital M equals capital M. So you have 3/4 equals m/4. 4 cancels off. So capital M equals 3m. Capital M equals 3m. Then simple M, the subject simple M, it should be capital M/3. Capital M/3. So the answer should be the first one for 13th question. 14th. An incompressible fluid flows through a pipe at rate 22 cubic centimeters per second. Speed of flow where the radius 3.5 centimeter is. Right. So there's a fluid and the flow rate is given as 22 cubic centimeters per second. So you know that flow rate is equal to A times V, cross section times velocity. Flow rate is given as 22. Cross section is so the pipe, that is pi r square, should be the cross section times velocity. So what they ask is this velocity. Pi I can consider as 22/7. Radius is 3.5 times 3.5. V 22. Now just simplify to find V. That's an easy question. 22 cancels off. 3 means 1, then 0.5. So we have 1 equals 0.5 is 1/2. 3.5 I can write it as 35/10 V. Then V is equal to 20/35 centimeters per second. 20/35. Just divide by 5 both, and then this becomes 47 centimeters per second. Answer 14 should be the third one, 47 centimeters per second. 15th, 2 pressure meters in air stream shown below. 1 meter has a reading PS, another one PT. Velocity of air stream is, so we have this air stream. As you can see, this is hydrodynamics. Fluid is moving. So here you measure the pressure as PS. So if you consider this is streamline, pressure here is PS, which is read by this pressure meter. Then the pressure here is PT. Just consider along a one streamline. So since this is a streamline, you can apply Bernoulli's equation. So the Bernoulli's equation says P plus pressure plus half rho V square plus rho GH equals K. We don't have to get rho GH because there's no change of elevation of the streamline. So pressure plus half rho V square should be a constant. Okay, so pressure plus this one here should be equal to pressure plus this one here. So the pressure here is PS. And so what they ask is the speed. Let's say speed is V. So half rho V squared. Let's say speed is V. I mean here what happens is speed becomes 0 due to this barrier. But the pressure is PT. Since speed is 0, there's no kinetic energy. Then I just substitute V. Sorry, subject V. So this becomes 2 PT minus PS divided by rho, root of that. That is the velocity of the airstream. Answer should be third one for the 15th question.